Okay, grade 8s, lesson 6. So the first lesson, the first part of this lesson, of course, whenever we start a new lesson, it's mostly the teacher demonstrating. I'm not going to spend a lot of time on this. I don't want to make a super long video on review that is supposed to be, fairly straightforward at this point. You always take the denominator, multiply by the big number. 2 times 2 is 4 plus 1, so this is 5 halves. Okay. Just rewriting this to make it bigger so you can see what's going on. 3 times 4, it's always the denominator times the large number, add the denominator. 3 times 4 is 12 plus 3, 15 over 4. Okay? I guess I was supposed to only do a video for this one, but I kind of felt like just rocking and rolling here. So, 9 times 8 plus 5. 9 times 8 is 72 plus 5 is 77 over 8. Okay? I don't mind doing these because they're guided notes. It's a review of a skill that you should already have. What does the acronym BEDMAS stand for? You know this by now. You saw that I've written this in pencil because it's really not in grade 8. I'm not going to go over that. Okay, so I'm making notes myself to make videos, right? All right, let's evaluate this. Well, frankly, this is a lot less complex than some of the harder questions in lesson 5, so this shouldn't take us too long here. We have BEDMAS, right? Do we have brackets? Yes, we do. Do we have division? Yes, we do. Do we have multiplication? No, we don't. We have addition, and we don't have subtraction. So we definitely got brackets first. We've got to do this. It's addition, but the brackets make it important enough that it comes before the division, okay? Brackets always wins. You guys know that by now. So, of course, this just has to hang out and wait, okay? So it's got to wait for a result here. Let's do it over here. What is the lowest common denominator for 6, 4? Well, that would be the 12, okay? So what does that look like when you're converting? We need a lowest common denominator because that's adding. We'd have to do that if it was subtraction. Okay. So in other words, we're going to multiply this by 2. We need these denominators to be the same. We need to convert. Okay? So what's the rewrite look like? I'm not even going to add in this stage. I just want to see what this looks like rewritten as the equivalent. There's that word again. One of Mr. Smith's all-time favorite words. So 5, 6 is the equivalent of 10 over 12. This would be the same mark on a quiz. 5 out of 6 questions correct is the same as 10 out of 12 questions correct, plus 1/4. So 1 times 3 is 3, 3 times 4 is 12. Now we're cooking. Okay? We've got the same denominator. Happy times. 10 plus 3, all over 12. This is by far my favorite step. If you're going to show me any steps when you add and subtract fractions, this is my favorite one because it shows you that you don't touch the denominator. You don't make this into some silly 24. You know that the denominator only shows how the pizza is sliced. It's not a counting number. It's a description number. That's a good way of putting it. 13 over 12, or, nope, I'm not going to change this because leave as improper. Why? Because we're in the middle of a question. We're not done the question. Leave it as improper. Don't bother with mixed until you're done completely. So we're going to reattach the question now. In other words, we're going to finish it. This 1/3 has been waiting. Okay? So what does this look like? 1/3 divided by what? Well, we got an answer now. It's 13 over 12. Okay. So this now ends up being, what's our strategy for division? Keep, change, flip. That results in, keep the first fraction as is, where is, don't touch it. Change the operation to its reciprocal. The reciprocal of division is multiplication. And in order to rebalance that, we need to we need to reciprocate, or you have to use the reciprocal of the fraction, the second fraction. The fraction that is being divided by, becomes multiplied by, and so you have to flip. So 12 over 13. Oh, look at that. Why is Mr. Smith happy? Because there's some cross cancellation available. 3 goes into 3 once. 3 goes into 12 4 times. Multiplication allows me, and I'm going to do it way down here, okay? Multiplication allows me to read this. Okay, just a little quick refresher. I can switch the dance partners. This, because the order of multiplication doesn't matter, this here is the same as 12 over 3 times 1 over 13. So that is reducible, right? 1/3, you can't do anything, but 12/3 you can. They can switch because the order of multiplication doesn't matter. All right, back to the program. Okay, what does that leave us with this cross cancellation? That leaves us with 1 times 4 over 1 times, hey, look at that. I love it when there's ones to multiply, don't you? Say yes, grade 8s, you love it. Okay, 4/13. Good.